Hi everybody. So this is lesson 1.3. So let's go ahead and open this handout and let's get started. Okay. So in this lesson, let's look at the objectives that we'll be covering. So we're going to, by the end of the lesson, understand that percentages are an important quantitative concept, that the percentages increase and decrease can be performed using one operation. We'll also be able to calculate the percent of a number, use percentages to solve contextual problems, and come up with the formula to calculate percentage. Now, you have experience using percent. Many of you remember the definition of a percent, right? So if we quickly just see what the percent is, I want to ask you to tell me in this question that comes up, what is a percent? Can you write a sentence explaining what the percent is? Okay, so percent is defined as amount out of 100, right? So that's the basic definition of a percent. And that's what we're going to be using in the class today, but in a maybe slightly different way that you have seen it in the past. Or maybe the same way. We'll see. All right, so let's look at the problem situation number one. Basic calculation of percent. All right, so here's the definition. Again, the percentage is a number expressed as a fraction of 100. Numerous application of percentage in everyday life, sales tax, credit card interest rate, field goal percentage, probability, steepness of a slope of a road, and many others. In this lesson, we'll look at several such applications. So let's look at the first example. The NBA player Stephen Curry of the Golden State Warriors, as you can see, this is somewhat outdated information, had the highest free throw percentage during the 2015-2016 regular season. He made 90.8% of his 400 attempted free throws, and we want to calculate how many free throws he made. All right, so let me give you a moment and calculate. Do you remember how this is done? All right, so let's go ahead and review this. So what does it mean 90.8? Well, it's a decimal, but the definition of a percent is amount out of 100. That means he made about 91%, which is about 91 out of 100 free throws attempts. Well, if you made 400, then the same ratio can be what we say prorated to a larger denominator. Okay, so we can say, well, he made another 91 out of 100, then another 91 out of 100, and then another 91 out of 100. About, correct? I mean, that's what that means. Why am I writing it four times? Well, because you have 1, 2, 3, 4 sets of 100, which makes it 400 attempts. So if we add these all together, we're going to get 1, 2, 3, 4, and then 9 times 4 is 36. So 364 out of 400 attempts. So that's if you reason this in terms of just understanding what the percent means. Now, if you want to do this in a more systematic way, so you follow procedure, which goes directly from the meaning of a percent, then you can go ahead and just do just as that. 90.8 means 90.8. It's okay that it's a decimal. It still represents the idea that it's about 91 out of 100. So you can write it as a decimal, as a fraction, and then you can either use a calculator or you can remember that whenever you're dividing it by 100, the decimal point moves two places to the left, so you get 0.908 right here, which is out of 1, which means exactly 98%, and that's per 1. So for each one, you get 0.908. So it is a fraction. It's like a standardized unit. But since he made 400 of such attempts, what you do, you're just repeating the same decimal 400 times. So just like here, adding the same number 4 times is equivalent as multiplication. If you want to find a percent of a number, which you're going to see very often in this class, you performing an operation of multiplication to describe that repeated operation. Okay, so in this case, if you want to know what is this out of 100, we're going to times that by our base, and then what we're going to get is the approximate number based on that percentage. So 0.908, I'm using my calculator, multiplying by 401, and I get 364.1. All right, so 364.108. I'm going to write the whole number in. So 364.108. But as you can see, since we're talking about the attempts, you're going to round it to the nearest whole number. So once you round this off, we got exactly that estimation. Okay? So that was a quick review of percentages. Let's go to the second question. So this is an application involving a credit card. All right, it's offering you a cashback bonus. This means that every time he uses his credit card to make his purchases, he earns a percentage of the money that can be redeemed at the end of the month. Okay. For instance, if you ever use Apple Pay, and let's say you use Apple Card, it gives you 2% return every time you using an Apple Pay, and then it stores your cash back in separate amount, and you can redeem to buying something. All right, so it's kind of the same idea where you're getting these rewards as a cash back returned to your card, and then you can use it for purchases. So now his particular card gives different bonuses depending on the type of purchase you get, type of the purchase. So that they call categories. Okay. So let's go ahead and put those categories in a table of format. So he gets 2% for supermarket. So whatever he buys at the supermarket, he'll get 2%. So we're going to sort of put that on the table. We're going to put the type, and then we're going to put the, the rate that he gets. And then over here, we're going to calculate the amount in dollars. All right, so let's look at the type. So we got supermarket. Give us a return of 2%. All right, the next one is pharmacy. Gets 5%. And then everything else that do not fall under those two categories, getting 1%. So it's not an additional percent, it's just 1% that does not fall in those two categories. All right, so let's go ahead and now write down the amounts that he spent in each of those. So he spent $431 altogether last month, of which $195 were used for 195 were spent on the supermarket. $45.36 were spent on the pharmacy purchases. And everything else we can calculate in a moment, but we do know that he spent a total of $431.57. All right, so I'm going to ask you, take a moment and calculate how much did he spend on all the other purchases. Okay, so to calculate that, we're going to take the total and we're going to deduct minus the other two categories, correct? Hopefully that makes sense. So we're going to deduct 195.30, and then we're also going to deduct 45.36 to see how much we're spent on the other categories. We're using a calculator throughout this course, so we don't do anything by hand. So we go ahead and minus first category, and then we minus the second category, 195.30 and 45.36. Perfect. All right, so we got $190.91. $190.91. I should have written there right away. Okay, now we're going to go ahead and calculate the cash back bonus. So we're going to make another column. We're going to call this cash back. And the idea here, just like in the previous amount, is that you're going to get a fraction of the amount that was spent. So we got the 2% of this, 5% of that, 1% of that. My question to you, what operation are you going to do to calculate cashback for each category? Are you going to add, multiply, divide, subtract? What are you going to do with those numbers? Please answer that question. All right, so here, just like in the previous example, since if we want to find a percentage of a base, then the operation here will be multiplication. So in other words, if we want to compute 2% of $195.30, you go ahead and multiply those two numbers. 2% is a number. It means 2 out of 100, or 0.02 as a decimal. It's like 2 cents for every dollar. That's the best way to think about it. Every dollar, you get 2 cents back. 2 cents, 2%. All right, but that's for every dollar. Since we got $195, that's where the multiplication comes in. So hopefully it's kind of a logical way, right? You don't just memorize that you multiply. It's the understanding that if it is a percent of the amount, percent represents amount per 100. So once you write it as a decimal, it becomes an amount per each one. 2 cents for every dollar. And since you have $195, it makes sense to multiply. Alrighty, and we're gonna do it for all. I'm gonna ask you a moment and type up the calculations for each. So write down the answers for supermarket, pharmacy, and all other, and then we're gonna write them down. Okay, so for the first one, we got 2% multiplied by 195.3, so that gives us $3.91. We're gonna round it to the nearest dollar. The second one is going to be 5% multiplied by 45.36. So that gives us $2.27. You can see the amounts are small because the percentages are pretty small. And the last one is 1% multiplied by 190.91. And that's $1.91. Okay? Hopefully you're okay with all these percentages, just to double check. Okay, make sure that these are the decimals that you got, and then you multiply by the amounts. All right, then let's go ahead and calculate the total cash back. So 391, 227, 191. So that gives us a total of $8.09. Final answer. Okay, so here's another application of where you can see percentages used in practice. All right, that's it. Let's go to the next question. All right, so for that, I'm going to use Excel. Okay, so let's look at the problem situation number 2, generalizing calculation with percentage increase and decrease. So here we have a situation where the Eduarda and Paula are starting a small business making and selling tie-dye clothing. They buy the clothing ready-made and then dye the items in colorful patterns. Eduardo and Paula plan to sell their products at events such as street fairs and festivals. They decide to set their prices by adding 65% to the cost of the clothing. This covers their expenses and gives them a small profit. Paula creates the following spreadsheet to calculate their prices. The cost of items is the amount Paula and Eduardo pay for the clothing, while the price is the amount they charge for the item to the customer. The formula bar at the top of the image right here shows the formula in cell C2. This formula is used to calculate the price when the cost is entered in a spreadsheet. All right, and Eduardo and Paula have a little uh, different ways that they want to do so. So Paula proposing the formula that's written right here, B2 plus 0.65 B2, while Eduardo is saying, well, we can just go ahead and multiply by 1.65 to get the result. All right, so who do you think is right? So take a moment and see which method would you use and explain why. All right, so again, they're trying to add 65% to the cost of the items. Okay, all right, so let's go over it. All right, so I'm opening up the Excel. I copied it here. All right, and we're going to go ahead. I can zoom in a little bit more. We're going to enter the formula that Paul is proposing, which is taking the amount here, B2, and we're multiplying it, or we're adding 0.65 times that same B2. Okay, here we go. We get $14.03. We can double click on that bottom right square, or we can drag it. That will repeat the calculations for every single item in the spreadsheet. So that's an advantage of a spreadsheet that we use. Okay, so that's the price. So that's the method that Paul is proposing. I'll just put the P in parentheses here to indicate that that's a Paula's proposition. And now we're going to go ahead. Where did my P go? Okay, here we go. And then here we're going to put Eduardo. I'll put E in the parentheses using his method. So he said, oh, he changed it to euro. I don't want that. Price. Here we go. So we're going to go ahead and use his method, which is taking the cost of the item and multiplying it by 1.65. And it appears to be that we're getting exactly the same numbers. So both methods are correct. All right, which is useful. Well, you probably thought that the Polish method is more logical, correct? What do? We had, a price, whatever it was. Well, not the price, it was the cost to them. I'll just use an example of the woman t-shirt. So you take $8.50, right? You multiply this by 0.65 to get the markup, correct? And that gives us, let's put that in a calculator. So $5.53. We call this a markup, the amount that you add to the cost. Okay? And then the price becomes the original price plus the markup, which gives us $14.03, the same answer. So that's basically what that formula is about, the way that the Pola calculates this. But let me ask you a question. How come Eduardo's method also gives us the same result? Can you explain how does multiplying it by 1.65 produces the same answer? Let me give you a moment. Let me hear your response. Okay, so now can you go ahead and write your response in your notes? And that's right here. It says discuss with your group, but since we are doing this completely online, can you go ahead and write down, well, let's go ahead and write down justification as why, not only Paula's method makes sense, but the Eduardo's as well. Okay, I'm going to type it up in Excel since I have it already opened up. So what we have? We have Eduardo's method, 1.65. Let's try this. Let's break this down. So if we're taking $8.05, and we multiply it by 1.65, we get straight to that answer of $14.03. Let's try to reason out where's this coming from. Well, what is 1.65? We can write 1.65 as follows. We can write this as 1.00 plus 0.65, like that. Correct? That's still 1.65. And then what is 1? 1 can be thought as 100%, and 0.65, if you convert it back into percentages, is 65%. So basically that number 1.65 incorporate it itself the original cost, which is 100%, and it basically adds up another 65%. So if you look at this multiplication, when you do 850 and you're multiplying it by 1.65, you are using kind of like a distributive property where you are multiplying by, it's 65. You are multiplying 850 times 1, you see, like this. So you're multiplying it by 1. Let me maybe writing it like this. And then you also, at the same time as you're distributing, you're also multiplying it by, see, I'm distributing this right here, by 0.65. So in other words, when you're multiplying by 1.65, you're getting back what you started with, and in addition, 65%. I think the best way to see this is to kind of understand that a 1.65 is the sum of those two percentages, 100 and 65, which is actually equals to 165% of that amount. So that is why a Eduardo method also makes sense. Attaching the 1 gives back to what we start and that markup. Keep that idea in mind as we're going to be coming back to it. All right, let's continue with what's left in that lesson. All right, it says that the price of woman t-shirt is shown. Calculate the price of each remaining items. We've done it already, okay? So we already did it by dragging. You can also do this using a calculator, whether using Eduardo's method or Paula's method. Add up 65% and make sure you write down the answers for each of these items. All right. Now, alrighty, so let's take a look at the second question in this lesson. It says 6 months later, Eduardo and Paula are doing very well with their business. All for the products have sold very well. Paula and Eduardo have some items that have not sold. They decide to put these items on sale for 15% off. Calculate the sale price of each item after 15% discount and round your answer to the nearest cent. So what I want to ask you first, just focusing on woman t-shirt, the price is $14.03 at this time, and we're going to take 15% off. So go ahead and calculate what would be 15% discount. Alrighty, so let us now go over it. Let me go ahead and open this up, and we can type it up. I guess right here. Okay, so we have $14 and $14.03, and we need to deduct 15% off. Okay, so many of you might have done it by first finding what is 15% discount, correct? So what is 15%? Well, as we have been saying in this lesson, we reviewed the concept of a percent. Percent means an amount out of 100. So we convert 15% into a decimal form, so it's 0.15. And since we're finding what is that discount, we're going to go ahead and multiply this by the price of that shirt. Let me just make this bigger. All right, so we're going to multiply by $14.03. Okay, so let's go ahead and do this. So we can use a basic calculator here. Okay, so we got $14.03, and we're going to multiply it by 0.15, and that gives us $2.10 off. Okay, and then we're going to go ahead and deduct that from $14.03. So it's $14.03, and we're going to minus $2.10 to get the price. Okay, so I'm going to subtract 14.03, so it gives us $11.93. Okay, $11.93. Here it goes. So that's a traditional way that you would compute the percent discount, right? You find what the percentage is, and then you take it away from the price. Okay, so the next question, and we can do it for each one of them, but we would like to make it a little bit more systematic. So what I want to ask you is to think of a formula that, let's say, Paula could use in the cell D2 right here, so that we can find the price of the shirt after the discount. And if you can think of the two different formulas, then you can type them both up. Okay? Alrighty, so let's go ahead and review. So we're doing a discount. I'm using Excel here again. That's where I'm going to be entering the formula. So we'll look finding discount, which is 15% off. So that will be, if we use a Paula's method, we're going to do it the similar way as we did this with the markup. Okay, so we're going to go ahead and take 15%, and we're going to multiply it by the price, $14.03. So that's the same $2.10 that we got earlier. But remember, then we have to deduct it from the price of a shirt. And the key here is from. So if I just minus the price right now, it's going to give me, the right answer. But you see how Excel putting that in parentheses. Parentheses in Excel means it's a negative number. We don't want the number to be negative. The number is positive. That's the price that we are selling the shirt at discount. So what we're going to do, we're going to rearrange this. So we're going to write this way. Okay, so in other words, look at this formula again. It's D2 minus 0.15 times D2. It's these two operations written in one formula. You see it? Okay. Alright, so now we can either double click on that box in the bottom right corner, or we can drag it down to repeat the calculations for each of an item. And make sure you put that in your notes of what the discount would be. Okay? Alrighty, now perhaps some of you were thinking of a different way to do this. In particular, I would like to focus on the method that was used earlier. Remember the Eduardo's proposition was to take the price, it's right here, and multiply by 1.65. So could we think of kind of a similar idea here? Alright, let's think about what that means. So when we're looking at discount, let's break it down into pieces. What does discount mean? Well, you can think of it that way. Is that the original price was something, but that represents 100% of the value of a product. Correct? That was the original price. When you do a discount, which is in this case 15%, that percentage is being deducted from the original. Well, if you take 15% and you deduct 100%, what would be the new price as a percentage? Absolutely correct. It's going to be 85%. You see what I mean? It's 85% of what it was before. So, in other words, if we want to calculate the new price, alright, the new price is 85% of the original price. Original price. So if we would like to demonstrate it right here, you see how it was 1403. So to get that answer in sort of like one calculation, we can calculate that same discount the same 15% by taking the original price and then multiplying it by 85%. Check this out. Take the original price and then you multiply it by 85%. And you're still getting 1192. Here it goes. And if we drag it down, we're going to get exactly the same answers. So that's a little bit more efficient way to calculate the your discount, right? So something get deducted by 15%, that means you are paying 85% of the value. So if you want to kind of break this down using kind of the same idea as we did it with the discount, is like this. So the price was $14.03. Check this out. And then you multiply it by 1 minus 0.15. This is basically what's going on. The 85% represents 100% minus 15%. So if you distribute this, check this out. You're going to get 14.03 times 1, which is the original price, minus 14.03 times 0.15. So by looking at that distributive property, you kind of see what's going on right here. You see the original price minus discount. So that number, 0.85, incorporates two things together. Alright, so hopefully you could see it. We'll also see the same idea coming back to us at the end of the course. So retain that concept. Alrighty, so those are the two kind of formulas that we could use. We could either use original price minus 0.15 times the original, or we can multiply by 85% in one shot. Alright, now let's use that same idea and answer the last question here. It says Paula and Eduarda have a few skirts that do not sell even after being discounted, so they decided to take another 15% off. Eduarda says that this will be the same thing as taking the 30% off, but Paula disagrees. Who is right? And then calculate the sale price. So I'm going to ask you this. Answer the question. Do you think that taking 15% followed by another 15%, is it the same thing as taking 30%? Yes or no, and explain. Go ahead. And the second thing is, let's go ahead and look at the sale price. Alright, so first, the answer to the first question is taking 15% followed by another 15% is not the same as 30%. Alright, and the reason, hopefully, I'll read your responses to see if your reasoning was right. But the idea here is that once first 15% is deducted, the price goes down. So then you take another 15% of a lower price. The discount gets lower because the price is already lower, so it's not going to be the same, all right, because base changes. And to demonstrate this, we're going to take a look at, what is it, a skirt, right? It says a skirt. So going up to cost of the skirt, which is $23, let's go ahead and look at $23. Now let's go ahead and take the discount 2 times using the method that Eduardo proposed in the earlier method, which is doing it in one step. So if you do it at one step, how do you calculate 15% off? So what would be 15% off of $23? Please write your answer. Okay, and we're going to calculate that in one step. Whatever way you did it, that's great, but I want to focus on that one step. So if we want to take 15% off, we're going to multiply by 0.85. Okay, and we're going to write that answer. So let me clear it right here, and let's calculate it. So it's $23 multiplied by 85%. So it's 1955. That's the same number that we had it in Excel. All right, so that's 15% off. Alrighty, now we're going to take another 15% off, so we're going to repeat the same step. We're going to take $19.55, and we're going to multiply it by 85% again. Alright, so what would that be then? It's already in here, so convenient. So we're just going to multiply it by another 85%. And that gives us 1662 as the final answer. 1662. So that's another 15% off. Alright, now let's compare this to 30% at once. Alright, so what would be 30% at once? Please write your answer. Alright, and I'll do this in one step once again. So if it's a 30% off, then what would be the percentage that you will deduct? In other words, what would be the percent that this product is going to be valued at as a percentage? So 30% off means 100 minus 30, which is 70% off of the amount. So we're going to take $23 and we're going to multiply it by 70%. I'll write it as 0.70. You can write it as 0.7. It's just so you could see the percent built in there. So 0.70, 70% of the value. It's 30% off. It's still 30% off. So it's 23 multiplied by 0.7. So that would be 1610. Notice that that is lower than to take it 15% in a row. Okay, so when you do 30% at once, it's not the same answer. So this is not the same. It is lower compared to taking 15% followed by another 15%. So that's lesson. We sort of reviewed the meaning of a percent and how to do the discount and markup and general computation of the percent.